All right. Hello. We are covering 5.2 sum and difference formulas. So take notes and make sure you are checking in for attendance. Okay. 5.2. 5.2 covers the sum and difference formulas. We have a sum and difference formula for sine, cosine, and tangent. Okay. And then in the next few sections, we get some more formulas. So usually at this point of the semester, I give you guys a formula sheet with all of these starting with 5.2. I will try to look for it and I will post it online. It's nice to have when you're taking the test because you have them all in one place. Okay. All right, so sum and difference formulas. So we'll start off with cosine, and then we'll end this video there, and then I'll do a second one, which covers the sum and difference formulas for sine and tangent, and then the third video looks at uh, more complex problems. Okay, all right. So cosine of a plus b. So we're going to look at the sum, and we're also going to look at the difference. Okay. So when you're taking the cosine of the sum of two angles, like maybe you're doing cosine of 30 degrees plus 45 degrees, we could, well, 30 and 45, those are kind of easy because we know them, right? But if you add them, that's actually cosine 75. So we use these formulas to evaluate these other angles that we don't have memorized, right? We have 30, 45, 60 memorized, and the quadrantals 0, 90, 180, 270. But we don't have something like 75 degrees memorized. We don't memorize cosine of 75 degrees, right? So we could, and not for all angles, but like for some of these angles, like 75, we could evaluate it using the sum and difference formula. Okay, so this is how it works. Cosine of a plus b is going to be the cosine of that first angle, A, times the cosine of that second angle, B, minus sine of that first angle, A, times the sine of that second angle. Okay, and so this is your first angle, this is your second angle. All right, and then the formula, the difference formula. So if you're doing the cosine of A minus B, then that would be the cosine of A cosine B plus the sine of A sine of B. Okay, so these will be on the formula sheet. If I forget to post the formula sheet, please email me or text me. Okay. All right, so let's take a look at an example. Okay, so you might be asked to find the exact value, which means that whenever we see this, find the exact value, you're not using a calculator, right? Find the exact value for cosine 75 degrees. Okay, 75 degrees is not one of the ones we have memorized, right? Okay. However, we could split up 75 degrees into two that we do have memorized, and then we can use one of these formulas. Okay. All right. So it is helpful when you are doing this section to have the angles written out, the ones that you memorized. So we have like 0, 30, 45, 60, and then 90, and then all of the reference angles as well. So like 120, 135, 150, 180. You can stop here. You'll probably be able to find two angles that work if you do 0 to 180 and all of the reference angles in quadrant 2. Okay. All right, so this is helpful because if you're trying to find the exact value of cosine 75, we don't have this one memorized, but we have these memorized. And so what you want to do is try to find two angles here that either add up to 75 or that subtract to give you 75. Okay, so, and there could be more than one combination. So long as you find one, uh, just use that one. Okay, and it doesn't matter if there are other combinations that make 75. You can use any of them and you'll still get the same answer. Okay, all right, so I see that 30 and 45 add up to cosine 70 to 75. So that's what I'm going to use. So here, cosine 75 degrees, what I'm going to do here is I'm actually going to break up the 75 degrees as a sum, 30 plus 45. Okay. And once I do that, now I can use this first formula over here where A is 30 degrees and B is 45 degrees. So that's what I'll be using here in the formula. A is going to be 30 degrees. So here will be 30 and 30. And B is 45 degrees. 45 here and 45 here. And I can find the cosine and sine of 30 and 45 without a calculator because those are one of the ones we memorized. All right, so using the above formula, let me bring this down a little. Okay, so it's going to be cosine A. A is the first angle, which is 30. It doesn't matter which way you write them. You could have written it as 45 plus 30. That's fine too. You'll still get the same answer. And then cosine of B. B is 45 minus the sine of A times the sine of B, which is 45. Okay, and we have these memorized, so we can find the exact value of each of these. Cosine 30 is square root 3 over 2. Cosine 45 is square root 2 over 2. Sine of 30 is 1/2. And sine of 45 is square root 2 over 2. Okay, and when we multiply this out, we get square root 6 over 4 minus square root 2 over 4. And they have common denominator, so I can go ahead and combine these, but not really because they are not like terms. Okay, so this would be your final answer. Okay, let's try another one. Find the exact value of cosine 15 degrees. So 15 degrees is not one of the ones that we have memorized, but let's take a look at our list. Okay, so 15. I want to try to make 15 either by adding or subtracting two of these. And so here I see I have two choices. I can do 45 minus 30, or I can do 60 minus 45. Okay. Since we already used 30 and 45, I'll use 60 and 45 this time. Okay. Again, it doesn't matter which combination you use. You can use 45 minus 30. You'll get the same answer if you use 60 minus 45. Okay. So I am going to use 60 minus 45. And according to the difference formula up here, cosine of A minus B will be cosine A cosine B plus sine A sine B. Okay, so it's going to be cosine 60 cosine 45 plus sine 60 sine 45. All right, so cosine 60 is 1/2. Cosine 45 is cosine 45 is square root 2 over 2. Sine 60 is square root 3 over 2. And sine 45 is square root 2 over 2. Okay, so we get square root 2 over 4 plus square root 6 over 4. And so we get square root 2 plus square root 6 all over 4. Very similar answers you'll be getting because our answers are either going to be 0, 1, -1, 1/2, square root 2 over 2, or square root 3 over 2. Those are those are basically our choices for our answers for the ones that we have memorized, right? With a difference of signs. Okay, so you'll get a lot of these square root 2s, square root 6s, 4s. Okay. All right, let's take a look at another one. Um, all right, let's show that cosine x plus 2 pi equals cosine x. So this is kind of like your identities, right? Prove that this is true. All right, so let's choose a side. I'm going to go ahead and choose this side because that's the side that looks a little more complex than the other, right? So cosine x plus 2 pi. And now I'm going to try to get that to look like the other side, right? So here, the way I'm going to do that, in the last section, you used all of your basic identities and the Pythagorean identities. Here, I'm going to use my sum formula, the one at the very top here. Cosine, cosine minus sine, sine. Okay. So cosine x, cosine 2 pi minus sine x sine 2 pi. Okay, and then I'm going to simplify this. Again, we're trying to get it to look like this side. We have an actual angle here, but not here. Actual angle here, but not here. So let's evaluate the ones where we have an actual angle. All right, so we have cosine x times cosine of 2 pi is 1. Sine x times sine of 2 pi. Sine of 2 pi is 0. So we get cosine x minus 0, but cosine x minus 0 is just cosine x. And that's what we want. That's the other side, so we can stop here. Okay? All right. Being able to go in reverse if you're given something that looks like this. And since we're going to be dealing with sine and cosine formulas, and they look very similar, cosine has, here, let's go back to the very top. The cosine formulas have cosine, cosine, sine, sine, cosine, cosine, sine, sine. The sine formulas are going to be slightly different. Okay. All right, so be able to recognize which one it is. So here, if you see cosine, cosine, sine, sine, you know that it's going to be uh, a cosine of a sum or difference. So let's take a look at an example of what I'm trying to say. All right, so let's write cosine 5x cosine x plus sine 5x sine x as a single, it might say, they might give you a hint and they might say as a single cosine, or they might make you try to guess which one it's going to be, and they might say it's a single trig function. Okay. As a single trig function. All right, so you have to pay attention to the structure here. It's cosine, cosine, sine, sine addition. So that goes with cosine, cosine plus sine, sine goes with cosine A minus B. All right. All right, so cosine 5x cosine x plus sine 5x sine x is going to be equal to cosine of 5x minus x. Okay. And so that's just cosine of 4x. Okay. Let's try this one. Show that cosine 270 degrees plus b equals sine b. Okay, so this is more like the one just before this problem, this one. Okay, all right, so why don't you go ahead and try this one and then come back and see if you did the work the same way. All right, I am going to choose this side. This side looks more complicated. So cosine 270 degrees plus b. And this is the sum. So I'm going to use the sum formula, which says cosine 270 cosine 270 cosine b minus sine 270 sine b. All right, we have an actual angle here, but not here. We have an actual angle here, but not here. So let's go ahead and get the exact value of the ones that have actual angles. All right, cosine 270, that's going to be 0. Sine of 270 is -1. So we get 0 plus sine b, and that is just going to be sine b. And that's the other side, so we can stop. Okay? All right, so that is actually it for the cosine, sum and difference formula for cosine. The next video we'll do sum and difference formula for sine and tangent. All right.